Hi, Assalamualaikum. My name is Nur Farisha binti Muhammad Zuki. My metric number is 307600. Today I will present question A, which is find the interval where the function fx equal to 2x power of 3 plus 3x power of 2 minus 36x plus 4 is increasing and the interval where it is decreasing. So, to determine the interval, we first find the derivative of fx. So, f prime x equal to d per dx 2x power of 3 minus 1 plus 3x power of 2 minus 1 minus 36x power of 1 minus 1 plus 4. So it will be 6x power of 2 plus 6x minus 36. So we can factorize this as 6x power of 2 plus x minus 6. So we can factorize it further and it will be 6x minus 2 x plus 3. To find critical point, if f prime x equal to 0, 6x minus 2 x plus 3 equal to 0, we will get x equal to 2, x equal to negative 3. So we will get 3 interval. First, negative infinity, negative 3. Second, negative 3, 2. And third, 2, infinity. So for the first interval, which is negative infinity, negative 3, x will be negative 4. So we substitute the point into f prime x. So f prime negative 4 equal to 6, negative 4 minus 2, negative 4 plus 3. So the answer will be 36, which is positive. So fx will increase. So the second interval, which is minus 3, 2. So x will be 0. So we substitute it. F prime 0 equal to 6, 0 minus 2, 0 plus 3. So the answer will be negative 36, which is negative. So fx will decrease. So for the third interval, which is 2 infinity, x will be 3. So we substitute it. F prime 3 equal to 6, 3 minus 2, 3 plus 3. So the answer will be 36, which is positive, and fx will increase again. So the final answer, we can conclude fx is increased on the interval negative infinity, negative 3 and 2 infinity, and fx is decreasing on the interval negative 3, 2.
Hi, my name is Nura binti Azhar and my metric number is 307544, and I will explain question B, find the marginal profit function. Step first is define the profit relationship. To find the marginal profit, we start with the formula for profit. Profit is calculated as profit equal to revenue minus cost. Revenue is the product of price and quantity. The price is given by the equation P equal to 200 minus 0.98Q. Therefore, the revenue become RQ equal to 200 minus 0.98Q. Q equal to 200Q minus 0.98Q squared. Step 2 is write the profit function. The total cost of production is given by CQ equal to 0.02Q squared plus 2Q plus 8,000. Using the profit equation, profit is equal to RQ minus CQ. Substitute the expression for revenue and cost, which is 200Q minus 0.98Q squared minus 0.02Q squared plus 2Q plus 8,000, and simplify the term in PQ equal to 200Q minus 0.98Q squared minus 0.02Q squared minus 2Q minus 8,000, and it will be 119.8Q minus q squared minus 8,000. And step 3 is find the marginal profit function. The marginal profit is the derivative of the profit function with respect with QQ. So MPQ will be 119.8Q minus Q squared minus 8,000. And the derivative is MPQ equal to 119.8 minus 2Q. Thus, the marginal profit function is MPQ equal to 119.8 minus 2Q.
Hello Doctor, my name is Muhammad Amir Kambe Mamakir, metric number 307586. Okay, now I will explain question B2 Roman. To determine whether the marginal profit is falling or rising, we need to analyze its rate of change. We know the marginal profit function is MP equal to 198 minus 2Q. To find the rate of change of the marginal profit, we need to differentiate the MP function with respect to Q. The differentiate is d over dq MP equal to d over dq 198 minus 2q. After differentiate, we get the answer is negative 2. This result show that the derivative of the marginal profit is a constant which is negative 2. This means that the marginal profit is decreasing at a constant rate for all value of q. Therefore, we can conclude that the marginal profit is always falling and it's never rise because the rate of change of the marginal profit is always negative.
Question B, Roman 3. Determine the average profit AP function. So first we have pi, which is profit, and Q, which is quantity. So to find the average profit, we use the formula average profit equal to profit divided by quantity. So first, the profit function is given as pi q equal to 198q minus q power of 2 plus 8,000. Now, we divide the entire profit function by q to find APQ. So now, APQ equal to 198q minus q power of 2 plus 8,000 divided by q. So after we simplify it, which is we divide each term by q, so APQ equal to 198 minus q plus 8,000 divided by q. So the final answer is the average profit function is APQ equal to 198 minus q plus 8,000 divided by q.
Now I will explain question C, which is minimize the average cost. Step first is define the average cost formula. The average cost is calculated by dividing the total cost by the total number of unit produced. First is substitute the total cost, which is Cx equal to 0.02x squared plus 2x plus 8,000. It will be 0.02x squared plus 2x plus 8,000. And next is simplify ACX equal to 0.02x plus 2 plus 8,000. Step 2 is differentiate the average cost function. To minimize the average cost, differentiate ACX with respect to xx. ACX is d per dx 0.02x plus 2 plus 8,000. The derivative is ACX equal to 0.02 minus 8,000 squared. Step 3 is solve the critical point. Set ACX equal to 0, which is 0.02 minus 8,000 divided by x squared equal to 0. Rearrange the equation. 8,000 divided by x squared equal to 0.02 and solve the x squared. X squared equal to 8,000 divided 0.02 equal to 400,000 and take the square root of both sides. X equal to the square root of 400,000 equal to 630 and 3.46. Step 4 is verify the critical point. Since x is more than 0, indicating the ACX is concave up to x equal to 633.46. And the final answer is the average cost is minimized when x equal to 633.46 units.
Okay, now in this part, we need to calculate the price elasticity of demand when the quantity demanded is 10 unit. We are given the demand function is Q equal to 60 minus 2P power of 0.5, where Q is the quantity demanded and P is the price. We are asked to find the price elasticity of demand when the quantity demanded is 10 unit. Okay, first we need to substitute Q equal to 10 into the demand function, and we get 10 equal to 60 minus 2P power of 0.5. After solving the function, we find that the price when Q equal to 10 unit is 625. Next, we need to find the derivative of the demand function with respect to price, which is dq over dp. Okay, for the differentiate is dq over dp equal to d over dq 60 minus d over dq 2p power of 0.5. After differentiate, we get the answer is negative 1 over set p. Okay, now we need to substitute the value of p, which is p equal to 625 into the derivative, and we get dq over dp is equal to negative 1 over set 625, and the final answer we get is negative 1 over 25. Okay, now we need to calculate the price elasticity of demand using the formula ED equal to dq over dp times p over q. Okay, now we need to substitute the value into the ED function, which is ED equal to negative 1 over 25 times 625 over 10. And after solving, we get the final answer is negative 2.5. Therefore, the price elasticity of demand when the quantity demanded is 10 unit is negative 2.5. Since the absolute value of the ED is greater than 1, we can conclude that the demand is elastic at the price and quantity level. Okay, that's all. Thank you.